Assalamualaikum and hi, my name is Nur Batisha binti Yasrinya and I'm from IAC 5B. In this video, I show how to complete 5 different labview exercises, including signal simulation, data acquisition using virtual hardware, map script filtering, report generation, and remote panel setup. This is a great overview labview core features. So let's start with exercise 1.
Okay, for exercise 1, overview of the task. In exercise 1, the purpose is to create a simple labview VI that simulate a sine wave and display it on a waveform graph. I also add a limit control and alarm LED that turns on when the signal exceeds the limit. Step-by-step demonstration is: first, I place a while loop from structure palette. Then, I use the simulate signal express VI to generate a sine wave. Then, I add a waveform graph to show the output. Next, I drop a vertical pointer slide as the limit and around LED for the alarm. On the block diagram, I wire the signal into a comparison function and connect to the Boolean output to the LED. This shows how data flow continuously through the loop. Next, for real-world engineering application. For this application, this method is commonly used in monitoring system, like we detect when the temperature, pressure or vibration exceed the safety limit. Lastly, for ending summary from this exercise, I learned how to simulate signal, use loop wire function, and build simple logic using comparison. Okay, next we move to the second exercise. First, for the overview the task, in exercise 2, the purpose is to do data acquisition using a simulated and IDAQ device. This let me practice collecting and analyzing signal without a real hardware. The step-by-step, we create a simulated device in NI Max. Then, in labview, I place a while loop and insert the DAQ assistant, and I choose analog input. Next, voltage and AI0. After that, I add the time delay, so the loop runs every 0.1 second. I also add a waveform graph and a statistic express VI to calculate mean, minimum, and max value. Finally, I use write to measurement file to save data. For real-world engineering application, I think this method used in real task function machine and sensor where engineer continuously record and analyze live data. Last but not least, for the summary, I can learn how to figure virtual hardware, collect continuous data, how to analyze value, and save real-time measurement. For the exercise 3, overview of the task, the purpose is to use MathScript node to generate signal and noise and apply a moving average filter using text-based scripting. And step by step, first we will open the MathScript node and type the code that calculate two signal, add noise and filter the result. Then I add output on the node border and wire them to the graph indicator. I also use breakpoints and the probe to show how variable change while running. For real-world engineering application, this method is used in signal processing area like audio cleaning, ECG, heart monitoring, and smoothing noisy sensor data. For ending summary, how to combine graphical programming with text-based coding and how to debug script inside LabView. For this overview of the task in exercise 4 is to generate a report that includes signal data and spectral analysis result. Step by step is we place the simulate signal express VI to create a waveform. Then I use the spectral measurement VI to perform FFT analysis. After varying dust output, I insert the report express VI and figure it to create an HTML report. When I run the VI, LabView automatically generate a report showing the graph and data. For real-world engineering application, this is useful in engineering test report, lab documentation, and automated data logging. In summary, I learned how automatically to generate documentation and how to combine multiply analysis into one clean report. Last but not least, for exercise 5, overview of the task is to publish a LabView VI online using remote panels so user can control it from a browser. Step by step, start with web server, open the web publishing tool and select my VI. Then I generate the HTML page. Once the web page open, I request control and run the VI directly from the browser. This shows how LabView allows remote access. And real-world engineering application. This is used in remote monitoring system, online lab, industrial machine control, and IoT dashboard. Last, for summary exercise 5 is we can learn how to host a VI online, allow remote control, and use LabView for web-based monitoring. Thank you.